on the topic of solids of revolution using the disk method. So assume you have a function like f of x and you start rotating that function about x-axis. As you can see, the cross-section is a circle, starting from smaller circles going to larger circles. The volume is pi, definite integral of the radius, which is f of x to the second power. Where does it come from? Remember the way that we defined the volume. It is the definite integral of the area of the cross-section dx. Remember the area of a circle. If you have radius r, the area which depends on r is pi r squared. So since the cross-section is basically a circle, it means that we're going to use the area of circle formula. In this case, it is going to be the definite integral of pi f of x to the second power dx. Please pay attention. R is f of x, and r squared is f of x to the second power. The radius depends on function f. So you're using f of x as radius r. Then we take the definite integral over pi r squared or pi f of x to the second power. In this question, you want to find the volume of solid generated by revolving the region bounded by y equals to square root of x and the lines y equals to 1 and x equals to 4 about line y equals to 1. Very well. This is basically y equals to 1. Now, the top function is square root of x. The radius that you're looking at is this slice here, which is square root of x minus 1. We find the distance between these two functions to have the radius. Now we are starting rotating this object about y equals to 1. This generates the following solid for us. So here you have square root of x rotated about y equals to 1, which is this object. And as you can see, the cross-section is a disk, a solid circle, and this radius or the distance is square root of x minus 1. As you remember, the volume formula is the definite integral of pi r to the second power. R is this radius or the distance with respect to x, and x ranges between 1 to 4. In turns, it is equal to the definite integral from 1 to 4 of pi r of x is square root of x minus 1 to the second power. Again, the distance or the radius is just right here. The top function minus the bottom function, or the ceiling minus the floor, gives you this distance or the radius. But you need to raise the radius to the second power. This is pi r squared, or the area of this disk or circular region here. We are taking the integral with respect to x. R of x is square root of x minus 1. And again, we are paying attention here. This distance is square root of x minus 1. And we are just substituting that over here. In turns, it is equal to pi, the definite integral of, now we're going back to algebra. We get square root of x to the second power, which is x, minus 2 times square root of x times 1, plus 1 squared, which is 1. We're taking the integral with respect to x. Remember that for all of these, we're using the power rule. The integral of u to the n du is u to power n plus 1 divided by n plus 1 plus constant of integration, which in turns is pi. The integral of x is x squared divided by 2 minus 2 times the integral of square root of x is 2/3 x to 3/2 plus the integral of 1 dx is just x. X ranges between 1 and 4. When you plug in 4, then you plug in 1, do the subtraction, it becomes 7 pi over 6. So the volume of the solid of revolution with respect to the line y equals to 1 is 7 pi divided by 6. The most important part for you guys is to identify and recognize this distance or the radius. So I expect you to ask, what if this one was y equals to -1? It means that you get a larger distance here. You have square root of x, then plus 1, because you get a larger distance. So please pay attention. What is the line? Where is it located? It's super important for you guys to visualize what do you have and what you are calculating.